more sensors. More sensors is a little bit robust, a little bit reliable of the shelf. But for sure, we are also from System, we also develop our own sensors. My dear good friend already passed away, Dr. Supri, is developed own sensors, but still cannot use for commercial. It's not reliability. They are developed the conducting polymer sensors, but I am using the most sensors. Alright, then we have to develop our own chambers. So from the sensors, we have to develop our own chamber. We have to simulate the type of chambers, what are the area of chambers, the flow, and what are the pump being used, the speed of the pump. We have to do this kind of simulation. Alright, this is some of the simulation. So inside that, the airflow should be laminar. It should be less than 2000. Okay, to enable it to the air to contact the sensors effectively. So it should be in laminar flow. Alright. Then for sure, the heart of the INOS is microcontrollers. The one that we are using right now is the SPIC. The SPIC is a 16-bit. It's quite good. This is our board. We develop our own board. Okay. Then we have RF wireless. Previously we have wired RS-233. Then we have ZigBee. Okay. Then we have XB. Then ZigBee. Then we have Nordic. Now we have LoRa. This is of the technology that we are using for this wireless communication. Because it's a portable device, so we have to calculate the total power consumption, the total power that being used by the instrument. So right now it's almost 3 watt. Because you can see the more sensors is hot, we are using a lot of power consumption. But for the world, normally we are using batteries, eco batteries, dry batteries, whatever. Okay. I don't want to go details on these technicals. Okay, this is the enclosure. The enclosure, we are using the first one. The first version, we are using our own 3D printer. Same with the second one. Second version, we are using the 3D printer. It's very nice. We can develop our own enclosure, whatever. But the problem is heating. Heating will, when the materials will heat, they will emit another chemicals that is not good for our device. That's why for the third version, whatever, we are using out the shelf enclosure, because of the smelling odor that emit during testing. This is software you see. I don't want to go into details. Software. Then we have to generate this GUI using VB6 to communicate with the developed device. Alright. This is the process. The process, we have samples, order samples or A samples. Then we are using the electronic nodes or the developed electronic nodes to collect the data. Then we analyze using ANN or PCA. PCA is for cluster. ANN is for classification. Then this is for this application. Either we are going to detection, either we are going to grading, monitoring, and classification. This is some of these application. Alright. So after develop, we have to be test. Normally we are using ordinary smell, food essence, that is banana, rose, strawberry, and vanilla. So this is the specification for testing. Then this is for Alright, this is the sensors response. Then from that we are taking the feature section, because the sensors is only, we have dynamic and static. So we extract only on in the static portion. Okay, we extract around 200. Then using digital filter to filter it out. Then we are using baseline manipulation. Baseline manipulation, that means we are comparing the ambient air with the sample. Then our data should be the difference between ambient air and the samples. So this is our real data. So we are using a novelty test to test the data is either linear or non-linear, parametric or non-parametric. And from that we can see that samples can be classified into 4 clear categories, either using PCA or LDA. That means our developed instrument have been working perfectly. Not perfectly, accordingly. That means alright. So we are using ANN to look at the classification rate. So this is the classification rate actually. RBF, I think something wrong with the RBF. It should be better, higher. But this is from practicals, from experiments. I think some of the configuration have to be checked. But MLP and PMN is quite good for this basic smell classification. Then we have to calibrate. So this for Garona application, we calibrate this XNL. So it's certain concentration, 200, 400, 800, 1000, 1100, etc. So for outdoor application, we calibrate using ammonia. That means our device, our developed device, has been able to respond to certain varieties of ppm concentration. So you can see it can respond to a certain concentration, various concentration. So we also doing this embedded in MLP for this basic smell. This is a session rate. This is quite good, but can be improved. This is maybe of the design itself, maybe because of the sampling itself process, then maybe of the computational process itself. This is the session rate. Alright. Then we go a little bit for history. We start in 2006. Dato' Ali masa tu ajak saya join this project. The detection is for Ganoderma fungus detection. Ganoderma is one of the fungus that destroy the palm oil industry. Okay. So we got bronze at ITEX 2006. This is our first version. Then the next year we developed second prototype. This is the prototype. We are using rabbit. The application is still Ganoderma, and then we got grant from Felda. This is a vessel stem-borne disease early detection. And we go to US for this impact exhibition. US. Myself and Bro Ahmed go to US. 19 hours flight from KL to LA. Tobat dah. We got silver. But we are improving. Okay, then in 2010 we developed our third prototype, still for BSR. But now the microcontroller or the engine of the system we change to microchip ESPIC33. So this is the engine that I'm using now. So this is the version. We got bronze medal for in NT. That's the history. Okay, that's the first part. Okay, second part, we are looking at the application of the electric loss. So my first application is in environmental monitoring. Alright, first we call it chicken. It means we want to control the disease in the chicken barn. As you can see, chicken barn, now we have a closed system. The barn is fully aircon. It's a closed system. So we have to control the humidity, we have to control the temperature, temperature. So we also monitor the hazardous gas. Normally it's ammonia, then hydrogen sulfate. This is to reduce the disease and growth rate. Alright. Then we also monitor the power failure inside the barn. Alright. So we develop four neutrinos with one main. We put inside the barn in pokok sengal in Kedah. Okay. So they can control the hazardous gas and climate of the barn for 36 days. So one cycles for chicken breeding is 36 days. So it control the power failure, then send SMS and contact the web base for remote monitoring. So anything unusual about the temperature, anything unusual about the ammonia level, anything unusual about the humidity, we send the signals to the staff or the owner. Then we have a control mechanism. Alright. So send SMS, anything. So if the ammonia level is higher than the usual, or the pattern that the ammonia level is unusual, so we send the SMS and activate the hazard lamp and alarm. So we control the cooling pad is the aircon and the exhaust fan. Okay. So any power failure, you will control the backup generator. Power failure, you automatically on the backup generator. Also linked to web system, we have a RM sensor. Because chicken, if the temperature is a power failure, half an hour or the chicken will die. We have 9,000 in one barn. 9,000 because it lost, total loss. Alright, so we are using a network. Okay, star. Then also this GSM. GSM is for SMS and for send data to the server. Alright, this is the monitoring. Okay, monitoring this. Okay, this is what are the temperature, the humidity for the whole 36 days. We have to control this one. Normally the tolerance will be in, for temperature 2 centigrade. So certain days, it should be the temperature. So we have to control the temperature according to age of the chicken. Okay, then we have to monitor the hazardous gas pattern, the ammonia and the hydrogen sulfate. If the pattern, something wrong with the pattern, it will trigger the alarm. That means maybe something wrong with the chicken. Okay, the ammonia is really quite high. Maybe the drinking water is leaking or whatever. Ammonia inside the chicken. Okay, this is the we can see the location of the chicken barn. Outside, moderate and high. This is the LDA. This is the chicken barn. Normally it's 50 to 80 to 100 feet. It's quite long. Alright, this is the mapping. On the 5 weeks, we have data, take data for the 1 week, week 1, week 2, week 3, week 4, week 5. Then we try to develop this kind of pattern in the concentration of the maladon. Maladon is a black smell inside the chicken barn. So this is the pattern you can see. On the 36 days is more smelly. Alright, then we send the data to real time This is my web. It's a RAM sense. It's quite basic. Quite basic. We have to learn it further. So this is a real data, time, what are the sensors that involve, the temperature and the humidity. Okay, we also control the power failure, the power system. As I said before, that means in power failure, it automatically convert the genset. The genset can be last for 2 hours for this chicken run 2 hours. Okay, yeah, I got this knowledge transfer for this project. Right? This collaboration with Laboratory and Assoc. This is our IP. This is the water. It's quite numbers of water. I-text, NTE, British, NTA, and Korea. Quite numbers of water. But now we are talking about pre-commercialization, that means to reliable of the systems. Hopefully at least we can commercialize this one. Okay, second application, go maybe directly, is we are using individual indoor amplifier to control the indoor air. We are using golden cocoa, we are using a bamboo plant, we are using another one, this is a tree plant that is quite good to absorb from the air. So this is for the our air. Alright. So because of the indoor pollution, that normally is BRI and SBS. This is two common diseases for the indoor environment. So you are using the plant to monitor and to control the indoor air purifier. Right. Basically, this is the system using indoor air plant. Alright, the system is the same, the simple. We have a data collection, monitoring, and we send to the internet. We also control the plant using microcontrollers. The fertilizer, watering, whatever, is being controlled by the microcontrollers. We also send to the web-based systems. Okay, this application normally is for indoor air monitoring for office, rest area, common room, etc. We try to propose this one. This is our IP. We have a right so open for IP. Alright. This is our collaboration. This is our award. I text. Then we go to this London. Okay, third for this environmental application is this for we say mobile profession. So we have a first version, we have second version, third version, now we have a fourth version. We have tried to put the Enos on top of the robot that can be work, can be mobile throughout the environment. Alright. So existing methods, they are using log, they are using chicken, live chicken, throw inside the confined space, see the chicken is still alive or not. That now, then there is meters. So the technician will go down to top, take the reading of the ammonia level, carbon monoxide level, whatever. But now we are proposing using robot and neutrinos that been go inside the confined area, take the reading, whatever. Then also take the reading during the operation. That means for confined space working environment procedure, normally you should take the data before you enter, while you are doing job, then after that, that means three stage. So what we are proposing is data collection, analyze, and send it to the real time. So we can monitor. What are the conditions down there. What are the conditions of the hazardous gas. Alright. So this is the live data. This is the GUI in front of the robot. panel robot, we have to put camera. This is our GUI. That means we have four location. We can know what is the carbon monoxide level. We can monitor what is the hydrogen sulfate level. We can monitor what is the ammonia level. Then we can trigger is any of these hazardous gas exceed the danger level. Alright. We also calibrate. The instrument. We are working with NIOS, BAMI, because it is involved in hazardous gas. Do the calibration over there to calibrate, to validate what are the gas concentration using this meter. That means our instrument emitter we compare validation. We have to validate. This is the application. Normally it's inside the confined space. Then we have to try to work out this landfill. Because landfill, a lot of hazardous gas involved. Normally got ammonia, carbon monoxide, and sulfate. So the robot will go through the landfill area to monitor this level of hazardous gas. Alright, this is our collaboration. I'm Dr. Perlis, Assoc, and we're working in this hospital, Bahaya, Kedah. This is we got a grant from Science Fund. This is our IP and copyright. This is our award. So we start in 2010. This is first version. Then second version we go to Geneva, Germany. Remember with Dato' Ali. Still remember after award tu Dato' Ali belajar ni lah. Salman saya ingat ni. Still remember. Then after that, this is our version. Then you see us need to go back again to this November 2014, and we go to ITEX 2017. So right now we are working on the version 6. Try to be pre-com. The reliability of the system. Okay. Then another application is ABDULLAH. This is an early warning system for Maradona emit from rubber factories. This is for outdoor system. Actually, we are working with rubber factories. The order from the factories normally during the monsoon season, the earlier monsoon season. That means the wastewater from the factories will be washed to the nearby river. This is quite problematic in Sungai Petani and Kulim. The waste from the rubber factories. See the same, we are talking about concentration of concentration of hazardous gas. We are doing this kind of index. If exit index, then we acknowledge with SMS and control environment. Then we also include these haze sensors. We also monitor the haze level in that area. So these four will be put around this factory's compound, and sent to the cloud, whatever. We also have portable solar panels that can be last 3 days because of the batteries and the solar. So when we do testing, we don't need their power supply. Just put there, we can monitor this one around for 3 days. That means we take 1 hour per data. That means in one day we have 34 data to look at the pattern of the odor, look at the pattern of the ammonia, etc. Alright, this is the sensors. This is the calibration. We have ammonia, carbon monoxide, hydrogen sulfate, sulfate dioxide. Alright, this is the factories in Sungai Petani, Teluk Timur. Okay, this is the grant that we got. Okay, this is the Kilang Getah, Teluk Timur. They are working for this data testing. This is our corporate. This is our exhibition. Okay, then Another application. This is for hazardous gas, LP gas. We are doing this one in Sungai Tani, same concept, whatever. Okay, to monitor this LPG gas, because LPG gas is quite hazard. Okay, this is a refurbished company, refurbished. That means the whole tank, whole cylinder. After some time, we have to go back to the factories to refurbish, to check the valve, to check the connection, etc. So, what's happened? The workers over there is normally the tank is not so empty. They just pull it again, then because just burst in the air. So it's quite dangerous. It's quite dangerous. So we are using this one, same. But with new technology, we try new technology. We are using BS P33. We are using this Raspberry Pi. Different technologies, but the same concept. Then we have to have a control environment. So we have a sprinkler, pump system, exhaust fan. So anything, this one will be triggered. Okay. Now we are testing it in Kulim. So this is the grant we got for this PPRN 35,000. This is the company start in Kulim Kilang Lama. Okay. Alright, this is our current project. That means we want to monitor the environmental. That means we want to combine water, air pollution, and noise. There's the three elements that we want to combine to monitor. Okay, the same. This is the element for water. Normally we are talking about pH, DO, etc. The gases, ammonia, hydrogen sulfate, carbon monoxide, etc. Then also put a noise. Because from the environmental point of view, if you want to monitor the environment, you should monitor three elements: wastewater, air, and noise. This is the same system block diagram: the industry, the gases, data analysis, and the control mechanism. Right. We are working with Jabatan Alam and also MSM Kilang Gula. Alright, that finished on environmental. Okay. Then we go to our third session. That means quality assessment using electronic system. So I also try using the electronic system for this quality assessment. Okay, first we are doing for this IoT class electronic system. Working with Mardi, last time Dr. Usman passed away. On using electronics to classify our own IoT class. Normally they are using human panels, but we propose electronics can be used to assist this quality control assessment, to assist the human panels. So this is the same, the samples, the collection, doing the analysis. We have our Malaysian rice Q74, 76, and 85. So this is the main sensors or main voltage compound for this rice. So we are using DSMS to monitor it. We develop our own neutrinos. This is sampling. Okay, we have IP on this one. We are working with Mardi last time. This is our board. Alright. Then our next project, our second project for this food grading is harmonized grading system. We are working with Mardi. We are working pharma to look at the harmonized Because harmonize, you can see during the season, we cannot differentiate the harmonize. First, is it a harmonize or are the mangoes? Second is either from Perlis, from Thailand, or from Indonesia. Because the harmonize from Perlis is quite expensive. So they need one system that be able to monitor, that be able to differentiate, that be able to identify. This is the true harmonize from Perlis. So we try to work on that thing. That means we propose a system combination, which is about sensors fusion. We are using vision for this shape. Most of them will need shape features to grade the harmonics, grade 1, grade 2, grade premium, grade 1 and grade 2, then size, XL, L, etc. We also using aroma to fuse the vision. We also look at the NR for the internal features. NR is very interesting because this is you can see the internal features. The internal features of the mango itself. We are using the cell to weighing the harmonics. This is for grading index. Alright, this is for the grading. That means XL, L, M, and S. Then we have a grading premium, XL 1 and 2. This is we are working with pharma for the first season. Then in early October or November, I have to go to pharma to further discussion on this project. Okay, third is on the disease. I think you tried this year. For the initial stage of Enos, we are working for this Ganoderma. This is the fungus, Ganoderma. We are working at the field in Assoc, near Sungai. So you can see this is a fungus. When there is a fungus on the tree trunk, the tree is already dead, just a cancer level 4. This is what we're working. And we also developed robot last time. Robot to roam the plantation. We also equip with this GSM and the GPS. The idea is to monitor where are the area that we detected, what area are healthy, etc. But we have the technology, but we test in Gunung Besau, there's no GSM signals over there. Okay. Then this is our comparative. We compare the existing technologies of electric in the market. We have Serenos. We also work with Serenos and System. This is the price. This is from Smith Detection US. This is quite from Caltex. This is from Caltex. This is quite technology. NASA, whatever, normally they are using this one to equip their space shuttle. Then we are using battery. Battery is from German battery. They are using more sensors. This is the price. This is from Italy. This is from ours. We call it Instinct. This is a price for 1 unit that we are proposing. We are also doing some research. But this is from 1 unit. We are talking about 4 units, etc. Maybe around 80K, something like that. This is our price for this developed instrument for commercialization purposes. With that, thank you.
TV dapat tahu kan?